Hi, and welcome to this AI in C# video on the Microsoft 18 framework. Today we're not gonna go into code too much, but instead explain RAG and how you explain it to other people. Because once you understand RAG, it's quite simple. It can be difficult to make accurate, but to people who don't know RAG in various levels of technical knowledge, it can be quite a daunting task to explain what this is. So this is my best approach that you can perhaps use when you need to talk to others. So what is RAG and why do we need it? Because we could just say RAG is short for Retrieval Augmented Generations. Any questions? That wouldn't make anyone wiser, it's just the name. So let's see some examples. So whenever we ask an AI something, it can be a simple question like, what is the capital of France? And it can answer Paris back. We can also ask much more advanced questions like Einstein-de Haas effect and get a bunch of information back. When you get the feeling now that, oh, this is a quite intelligent system I'm talking to. It knows all kinds of things, easy, hard, and so on. But then you can go on and ask, what's the Wi-Fi password at the office? And it have absolutely no idea. So it's this intelligent slash dumb experience that you almost always get from AI. But why can't it ask or answer that? That's of course because how would it know? Because we have the world of knowledge, and if this box represents all world knowledge, a lot of them it is the internet. It's the internet distilled, so we have taken away adult sites, malware, phishing, dark web, and such things. So all the, in quotation mark, good parts, and AI models are really, really good at that. The big models know everything. The small models know the highlights of what is in this data set. But there's other data in the world. There's your personal data, your emails, your bank data, your documents, and so on. You might access it through the internet or through the browser, but it's not something that are publicly available. And you probably wouldn't want it to be publicly available. If you suddenly went to ChatGPT and asked your innermost secret and it could answer, that would be kind of scary if you didn't have given that access to it. There's of course also company data, the company you work for, the emails there, the documents, the contracts with customers and so on. That's also not available out of the box for an AI. Other people's data, of course. You don't want your data to be out there. Of course, other people don't want their data to be out there. And then, of course, also some offline data, books, papers, things that have not been digitized or scanned in any way, and you can only get it offline. So that's why, of course, an AI can't just answer every single little thing in the world because some of it doesn't have access to. And RAG is the process of giving this data to an LLM and doing that on the fly because it doesn't know and it can't just be given and forever know it. But we can give it on the fly. So when I ask what is the guest Wi-Fi password at the office, I could, before I ask that question, tell it everything I know. And let's say everything I knew was this box. I know my name is Rasmus. I know my favorite color is blue. I know my parents' dog is called Mr. Buttons. I know the password to the guest Wi-Fi is guest42. I live in Denmark. I know John is in charge of support, and my birthday is on February 25th. If that was everything I knew in my mind, meaning things I have written down somewhere, and this was my world knowledge. I could put that in. It's not too much here. And then I could tell the system, I know all this, but what is the Wi-Fi password? And it would know, it would be able to pass this part out. And if I ask for the favorite color, it would be able to do that. I've just made it smarter by giving it more information. But in reality, everything I know is much, much more than just a few sentences, a few facts, and so on. And all I know is in different categories. Some of it could be easy to give. I have a bunch of documents on various things. I could just pass them into the LLM and give it some data here. But there's also a lot of messy data. There's binary data. I might have an image that shows where I've been traveling, and if I ask the AI, where have I been traveling to, or have I ever been to Australia, and I have a picture of myself in front of the Sydney Opera House, that would mean yes, but it's not really something we can just give the AI unless we pass that data out of the binary formats of data. And then there's certain things I have never written down. That's things that are only in my memory. Like, what is my favorite color? I haven't really officially written it down for an AI to get that. And much, much more. Meaning so much data. I'm not claiming I know a lot, but I'm just claiming that no matter who you are in the world, whatever you know as a whole couldn't fit into that box where you write your question. And even if it could, there is limits to the box. It can be between 128 to a million tokens. That's roughly between 500 and 2,000 pages of text. So I could definitely put in a lot there. But if I put in too much, it either goes information overload, or if it could barely fit, it might begin to actually have trouble finding it. It's like a needle in a haystack. Or it can be really slow to actually find it among all the data. So that is essentially why we need RAG. Because if we could fit everything I knew in the world and it was in a format that could be given, and we had infinite context, we could just give it everything upfront, and then ask the question, give it everything upfront, ask the question, and so on. But we need some kind of search index for everything I know. We still can't get my thoughts out, but we can at least take all the things I know that we feel is important to do this and begin to index it. A little like Google indexes the internet. It's not like Google have all the pages and have all the information on all the pages, but has summaries of it. It knows what that page is about and so on. So a kind of index, just like a library index where you have all the index cards and then can go to the real book. And that is how RAG actually is. So we take all the data that we want, that we feel comfortable putting into this index, and pass it into this search index, as we call it right now. And then we ask the question, and then we sort of search that search index for the words Wi-Fi, password, office, whatever we call it. And then we get a bunch of results back. So if I looked at everything I knew and all the documents I have and so on, I might know that the guest Wi-Fi network is guest 42, that my home Wi-Fi is Maverick 123, and my last Wi-Fi bill was so and so number of dollars, and so on. But when I did it like this search, it would give me the most relevant things back, not just random things or everything back. Sort of, if I go to Google and search for sports results, the links are to sports sites. It's not like to medical sites or anything like that. It's narrowing down. It's doing the search index like we are known with Google. And what we see here is kind of what RAG can do, because when we have all this data, the AI can answer, and this is RAG. So what we do when we take all our knowledge and turning it into our index, that is what's called embeddings and ingestions of data. So we take the data and turn it into an index we can search, and that index is called a vector store. And when we then query that search index or vector store, we're doing RAG search, where we're sending in some words and getting the most relevant versions back, meaning what is most similar to what we have put in. So let's put in 1,000 things and ask for the 5 most relevant ones. And if we search correctly and use the right words, we get the right ones back. And among the 1,000 things we know, we get 3 back, and luckily for us, that is enough to answer the question in this case. If we can't put it in the search index, or we search for the wrong thing, of course the AI shouldn't be able to answer still. But if we do this right, it suddenly becomes intelligent and feels like it knows everything about us. And it sort of does, but only by a search a little like Google. If we turn this into more technical stuff, if you are to be a developer doing this, then we can talk about that everything we know is source data. And we use some C# in Microsoft Agent Framework to clean that data, meaning all the messy data we turn into text. We get rid of all the things we don't want in the system. We get rid of filler words and stuff like that. So we get our data into a format that we feel is the best way that we can search in. And once we have that data, often in a text format, or it will often be in a text format, we then embed this data. Embedding being that we actually ask an LLM, so an AI up in the cloud like OpenAI or Google or something like that, and we use, instead of their chat models where we can normally get answers back, what is the capital in France and so on, we instead use what is called an embedding model. And an embedding model is taking text and turning it into what is called a vector. And a vector is normally something that are in 1536 dimensions. That could be higher for some of the models. So normally we have our 3 or 4 dimensions in reality, but in math you can have much more dimensions. And by having dimensions, you can plot into something that are multidimensional and figure out what is closest to that plot we just put in. And that is what the similarity searches of a vector store is. We put these vectors in together with the data into the vector store, saying this very, very long vector floating number, it's not one number, it's 1536 numbers. We take those, turn them into this vector and save it together with the data. And we put it into this vector store. And vector stores can be everything from Azure AI Search, SQL servers understand it, SQLite understand it, Cosmos DB, there's Quadrant, BV8. all kinds of providers, just like we have all kinds of providers of LLMs, or all kinds of providers of operating systems or phones or whatever we have. So a vector store is not something that's owned by OpenAI or whoever. It's just a way of mathematically representing data with a vector. So now we have done the ingestion part of all this. This is something that you might do every night or every 1 hour when a trigger happens, ingest a new thing. But it's something you do once, and then you update and add and stuff to that. So now we have our search index, our vector store. So we again come in with our question. And we saw it before that we searched the index, and that's what we do. But we don't search with text. We actually search with vectors. Because again, we have this big space of a lot of different vectors that are in a not three-dimensional, but multi-dimensional space. And we want to make a vector for what we are searching for. In this case, what is the guest Wi-Fi password? So we go to the LLM again and take this search query text and turn it into a vector. And once we have done that, we can make a vector similarity search. So if we search for the word kitten, it would come closer to cat than it would to a dog. And again, this is math. You don't really need to know the math. You just need to have these services saying, this piece of text you just given me here is closest to these texts. Because when you do this search, you say, among the thousands, let's say 1,000 records that are in the vector store, give me the 3 most that are most similar to what I've just written to you. And that's what's come back as a search result, often with a score, with a vector store score. They do it differently. Some of them do 0 meaning the best score, 1 being the worst score. Some of them say 1 being the best score. There's no standard of what is something. Someone goes from minus to plus, someone goes from 0 to 2. But you would take a vector store, you will choose what kind of score is a good number, and then it will give you the highest numbers back in these terms. So let's say it was 1 to 0, 1 being there's a text that says exactly what is the Wi-Fi password. But you could also write how do I get on the internet? Then it would also find the same, but perhaps with a slightly lower score. While if you ask, what's the capital of France? It will give you something completely different. It would have nothing to do with Wi-Fi and offices and so on. So it will give you some of the other source data. And then, of course, the AI would be able to answer because we have augmented our prompts with extra data, but not giving all the thousands of records we have in the store, but only the 3 that was the most relevant. With our risk of that the 4th entry in the most relevant is actually the one that has the data. If we ask for what is the Wi-Fi password, not specifying office or anything, and we knew 10 Wi-Fi passwords, it would probably, and we asked for 3 of them, we could hope it would give back the one for the office, because if we don't specify, or if the vector store don't specify, but it just have 10 different Wi-Fi passwords, even an AI, even you as a human wouldn't know which of those are the correct one. So then we could say, okay, then we go the vector similarity search. Let's take the top 10 best, but what if you have 11 passwords? It's always techniques and figuring out what is the best thing in this scenario, what is the best quality of the data, and so on. And that is the real part that are difficult with RAG. It's not the understanding of this. Yes, it can be. There's a lot of different words, but once you see a picture like this, hopefully it should be easy to understand what RAG actually is. And now it comes down to figuring out how to actually do this in code. And I have separate videos on that as well. So see you in the next one.